To this video, let's start with the solution of LTC AIIMS Chemistry Weekend Test number 15. Question number 1 regarding fullerene, incorrect statement is, so we are talking about C60, right? Specifically Buckminster fullerene. It contains 26 membered rings, correct. Carbon-carbon bond length is approximately 138 pm and approximately 143 pm. There are two types of bond lengths that are found in C60. So this statement is incorrect. Otherwise, the rest two are correct. It is aromatic, yes, and it is thermodynamically less stable than graphite, yes. Graphite, diamond, and C60, that is a stability order. Okay, guys. So this is the correct answer. Regarding carbon dioxide, the correct statement is yes, it is a linear molecule. It is not highly soluble in water. Its dipole moment is 0 because the individual bond dipoles, they point in the opposite direction. All right. So their vector sum is 0. It cannot act like electrophile. Yes, it does act like electrophile because of the double bond between carbon and oxygen, as in coal-based reaction. If you remember, CO2 acts as an electrophile. Okay, so the answer is this one, first option. The covalency of silicon and oxygen respectively in quartz, guys. Quartz is the crystalline form, one of the crystalline forms of SiO2, and you may remember the structure. It has a structure like this. So you can notice from the structure that each silicon atom forms 4 covalent bonds, whereas each oxygen forms 2 covalent bonds, right? So the correct answer is this one. All the following compounds are ionic except CF4 is covalent, AlF3, PbF4, NAF, they all are ionic. Number of significant figures. If there is a decimal place, the trailing zeros are significant. So there are there are three significant figures here, 9 and the trailing 2 zeros. Okay, so that is the correct answer. 10 grams of an element A combines with 10 gram of element B. So 1 gram of element A will combine with, of course, 1 gram of B. Now in another case, 20 gram of element A combines with 30 gram of element B. So of course 1 gram of A, this time it will combine with 30 by 20, that is 1.5 gram of B. So earlier we had 1 gram of B, now we have 1.5 gram of B. That means the ratio of their masses is 1:1.5 or it is 2:3. Is that clear? So law of multiple proportions, that is the correct answer. The correct, whichever one of the following statements is incorrect. 1 mole of sulfuric acid, of course, it contains 4 gram atom of oxygen, right? The other statements are correct. Benzene to benzene hexachloride, incorrect statement is it is an example of electrophilic. No, it is free radical substitution. Okay, the reagent used is Cl2 HNU, correct. IUPAC name is this one is correct. The product is not aromatic. Yes, that is also correct, right? So the product we are talking about is this one. Here, okay guys. In this question, C double bond ONA, this is sodium salt of carboxylic acid and this is soda lime, so this is decarboxylation reaction. So A would be benzene, and if you react it with the Cl2 excess dark anhydrous AlCl3, so this is electrophilic substitution, chlorination, and excess of chlorine causes the replacement of all hydrogen atoms by chlorine. So you get hexachlorobenzene. Okay, so this is a product. Regarding benzene, the correct statement is it strongly resists addition because that would result in loss of aromaticity. So therefore, it undergoes substitution more easily, much more easily than addition reactions. Okay. Carbon-carbon bond length in benzene is 139 picometer. Yes, it is intermediate between single and double bond because of resonance. And ethene and benzene can be distinguished by using Bayer's region. Correct. Ethene would decolorize the purple color of Bayer's region, but benzene cannot. Okay. This is pericyclic reaction, guy. Ethyne on reaction with copper at high temperature, it would undergo pericyclic addition to give you benzene, and then when you react it with conc H2SO4, it results in sulfonation. So the product is benzene sulfonic acid. This is the correct answer. Here you are using chlorine 1 mole at high temperature, so this is free radical substitution. It will occur on the alkyl part, so you will get benzyl chloride here, guys. Here we will get benzyl chloride, CH2Cl. And Cl2 in presence of Lewis acid catalyst, that is an electrophilic substitution, and you will get ortho and para substituted product, right? That means you would get toluene with chlorine at ortho and para position. So those would be the products. So this product is an aryl alkyl halide and this is an aryl halide. So that is the correct answer. Silver propanoate and chloromethane. This is a nucleophilic substitution. Silver propanoate is this Ag and chloromethane is CH3Cl. So this is nucleophilic substitution. Okay, this carboxylate will attack and it will get replaced. So this would be the product ester. This is benzene diazonium chloride, diazonium salt, and when you react it with Ki, the iodide replaces the diazo group. It gives you iodobenzene, and when you react it with CuBr, HBr, so that gives you the bromobenzene, Saint-Mears reaction. So that is the correct answer. Incorrect statement among the following is dipole moment of methyl chloride is greater. Yes, you might expect the dipole moment of methyl fluoride to be higher, but you know dipole moment is a product of charge into bond length. So for fluorine, delta charges are higher, but the bond length is less. So that statement is correct. Melting point of ortho dichlorobenzene is greater than that of para. No, para product has higher melting point because of the higher symmetry, right? Ortho has higher boiling point because of the higher dipole moment. So this is the incorrect statement. Rest all of them are correct. C2H5Cl with ammonia. This reaction is, guys, ammonolysis. You will find it under amines or under nucleophilic substitution. So if you take ammonia in excess, this yields you primary amine. But if you take the haloalkane in excess, that results in the formation of quaternary ammonium salt. Okay, so that is the correct answer in this case. Here, this is something you may have to remember because there are two nitro groups, so this compound will be extremely reactive towards nucleophilic substitution, but not as much as the compound which has three NO2 groups, right? So the mildest condition here is warm water. So that condition would work with the compound which has three nitro groups on all ortho and para position. So here the second mildest condition you might guess. So that is the correct answer. Number of benzene rings. Okay, so this is dibenzene thracene. Anthracene, guys, it has three benzene rings. It has three benzene rings, and dibenzene means there are two substituent benzene rings. So in total there are five benzene rings. C2H5Cl AgNO2. So you should know that here Ag plus and O minus NO, right? So basically oxygen has covalent, so nitrogen will attack. So C2H5N, and you should know that there is one dative bond in nitro group. There is one coordinate covalent bond. There is one here. And here because in KCN both cyanide both carbon and nitrogen are free to attack, but because carbon-carbon bond is stronger, so carbon attacks, and as a result there is RCN and no coordinate covalent or dative bond here. So 1 and 0 is the correct answer. Excess of ethanol plus 1 mole PCl3 will convert 3 moles of ethanol into chloroalkane, whereas PCl5, when it reacts once, it gives you POCl3. Okay, so it will convert 1. Okay, so the overall the sum would be 4. C2H5OH X C2H5Cl pure. The reagent X in this is a very famous Dassen's method, right? Because SOCl2, the use of SOCl2 in the preparation of chloroalkane from alcohol results in the formation of sulfur dioxide and HCl as byproducts, both of which are gases and escape easily from the reaction mixture. So that is the correct answer. Which one of the following is not a proper match? CuO is a semiconductor. Okay, all other three are correct matches. Molar conductance of 0.2 molar strong electrolyte is given a specific conductance. So it's simple, guys. Molar conductance, we know it's kappa into 1000 divided by concentration. So if the specific conductance is to be calculated, so it would be 540 Simon centimeter square mole inverse, which is the molar conductance multiplied by the concentration, which is 0.2 divided by 1000. So you can calculate, this will come out to be this much. Okay. Molar conductivity will be highest for trifluoroacetic acid because of the minus I effect of 3-fluorine. Its degree of ionization is highest. That is, it will give maximum number of ions per mole of the electrolyte. So that is why its molar conductance will be highest. Molar ionic conductance of calcium phosphate at infinite dilution are X and Y. So molar conductance for calcium phosphate. So guys, it's simple. Calcium is 2 plus charge, for phosphate is 3 minus charge. If you write the formula unit of the compound, that would come out to be calcium thrice and phosphate twice. Okay, so thrice the ionic conductance of calcium, which is 3x, plus twice the ionic conductance of phosphate, which is 2y. 3x plus 2y, that is going to be a correct answer. Brine solution is aqueous NaCl on electrolysis using inert electrodes gives this and this at anode and cathode respectively. Okay, so in brine solution, the ions present are Na plus Cl minus, and from water we get H plus and OH minus. Okay, now at anode, which species go? Chloride and hydroxide, but because of overpotential, hydroxide does not undergo oxidation, chloride does. It gives you chlorine. And out of Na plus and H plus ion has higher reduction tendency, so it undergoes reduction. So the products you get, that you get are Cl2 and H2. Cl2 at anode and H2 at cathode. Electrochemical equivalent of a substance is the equivalent weight of the substance divided by the Faraday constant 96500. Now, so basically you have to check out the equivalent weight. So for sodium, equivalent weight would be molar mass, which is 23 by n factor, which is 1. It only loses or gains 1 electron, right? For hydrogen, it would be 1 by 1. We are assuming hydrogen atom, right? Aluminum, it would be 27 by 3, which would be 9. And for magnesium, it is 24 by 2, which is 12. So highest is for sodium. Cost of electricity to deposit 24 gram of oxygen. All right. So oxygen molar mass is 16 gram and it takes up 2 electrons, right? It loses 2 electrons. So 16 gram of oxygen would involve a reaction with 2 Faraday of electricity, 2 moles of electrons, which is 2 Faraday of electricity. So 24 gram of oxygen would require how much electricity? 2 by 16 multiplied by 24. So this is basically 3 Farad of electricity. Now it is simple. 3 Farad of electricity costs 3000. So 1 Faraday would cost like 1000 rupees. Okay. Now cost of electricity to deposit 24 gram of Mg. Now obviously Mg, the N factor is 2 and the molar mass is 24. Okay. So we basically need 2 Farad of electricity and the cost of electricity per Faraday is 1000 rupees. So for 2 Faraday, it would be 2000 rupees. Very simple application of unitary method. Electrolysis of aqueous K2SO4 using inert electrodes is carried out by passing Avogadro number of electrons, which is basically 1 Faraday, guys, the charge on 1 mole of electrons. So the volume of the gas obtained at cathode. Okay, so the species are K plus, sulfate ion, and from water again H plus and OH minus. At cathode, reduction occurs out of K plus and H plus. Of course, H plus will undergo reduction. Hydrogen gas will form, and you can see hydrogen gas would require 2 Farad of electricity. So if you have 1 Faraday, you will only get half mole of hydrogen, and the 22.4 liter is the molar volume of a gas, assuming ideal behavior at STP. So for half mole, it would be 11.2 liter. Okay, so 11.2 liter would be the volume. pH of an acid solution in contact with hydrogen. So remember, guys, for hydrogen electrode, the reduction potential can be directly calculated using this formula, minus 0.0591. This term you know from last equation, multiplied by the pH. So this is a direct formula. Okay, right? The reduction potential of hydrogen, so pH is given to be 1. Okay, so multiplied by 1, and this would come out to be 0.0591 volt, which is 59.1 millivolt. So that is the correct answer. Molar conductance of 0.1 molar weak monobasic acid is 108 at the same temperature. Limiting molar conductance is 540. Remember, guys, the degree of ionization is lambda m at concentration C divided by lambda infinity m. So which in this case the values are given as 108 divided by 540. So this would be 1 by 5, that is 0.2. And percent ionization, of course, 100 alpha. You multiply it by 100, so you'll get 20% as the correct answer. Okay. Debye-Heckel equation is applicable only for strong electrolytes, because for them the variation of molar conductance with the under root of concentration is a straight line. Okay, so being salts, these are strong electrolytes, but this is a weak acid, not applicable. That is the correct answer. Regarding standard hydrogen electrode, the incorrect statement is hydrogen gas is bubbled at 1 bar. Correct. 1 mole HCl is used electrolyte. Yes, basically you have to maintain the concentration at 1 molar H plus, right? It can never act like anode in a galvanic cell. It can if the substance being paired with the hydrogen electrode is less reactive. Okay, its electrode potential is arbitrarily fixed as 0. Yes, that is also correct. So the answer is this. Difference in limiting molar conductance of KCl and NaCl. So guys, as per the Colruyt law of independent migration of ions, for KCl, the limiting molar conductance is the sum of ionic conductance of potassium ion and chloride ion. Okay. Likewise, for NaCl, it is lambda of Na plus lambda of chloride ions. So if you take the difference, chloride will cancel out. So this will basically be the difference in the ionic conductances of potassium and sodium. So this will remain same. Of course, in the second case, the difference in the molar conductance of KNO3 and NaNO3. So nitrate will cancel out. Again, it will remain potassium minus sodium. So that is going to remain the same. So X is equal to Y. So this is your correct answer. Identify the incorrect statement. Carbon 14 has very long half-life. In fact, in chemical kinetics of NCERT book, there is a question in the back exercise of the chapter. Silicon, no, oxygen is the most abundant element in the Earth's crust. Galena is PbS, which we also call lead glance. And copernicium belongs to carbon family. No, its atomic number is 112. So basically, it comes in the group 12, right? Zinc family. So all statements are incorrect. In the 14th group, this is a correct statement. Ionization potential and melting point are higher for lead than for tin. Okay. So remember these exceptions. Identify the correct statement about silicons. They are hydrophilic. No, they are hydrophobic because of the alkyl groups on surface. Okay. So this is incorrect. They have high thermal stability. Yes. High dielectric constant. Yes. They are susceptible to oxidation. No, they are resistant to oxidation. So the correct statements are second and third. Kekule's representation of benzene rings is this. No, actually, the concept of resonance was not there in the Kekule's structures of benzene ring, whereas you guys know that this arrow represents the resonance, right? Benzene molecule has 6 pi electrons. Yes, correct. So this is the answer. Statement 1 is incorrect. Statement 2 is correct. Regarding rhenium ion, guys, let me just tell you a little. For example, this is the benzene, and if we talk about the electrophilic aromatic substitution, then when the electrophile attacks, this pi bond breaks and it shifts to one of the carbon atoms, and at the same carbon our electrophile attacks, so you get something like this and positive charge. So this is what we call a rhenium ion. You can also call it sigma complex, right? Or sometimes we also call it Wieland intermediate after the name of the scientist. So basically, there is an sp3 hybridized carbon atom. It is resonance stabilized. You can see there are 2 pi bonds and a positive charge. But because of the sp3 carbon, the conjugation is broken, right? The resonance is broken. We cannot have a ring current. So this is not aromatic, okay? So regarding rhenium ion, the correct statements are, it is aromatic. No, it is stabilized by resonance. Correct. It's a carbocation, of course. And it is formed during electrophilic substitution action of benzene. That is also correct. So B, C, D are correct. N-propyl chloride FeCl3 is a weak Lewis acid, whereas anhydrous AlCl3 is a strong Lewis acid. It would generate enough positive charge on the primary carbon of propyl group that it would undergo carbocation rearrangement. So this would be your answer. In the first case, carbocation rearrangement will not occur. In the second case, it will. The aromatic species, you can see there are 2 pairs. So 4 pi electrons. So this is anti-aromatic. 6 pi electrons aromatic. 2 pi electrons aromatic. 6 pi electrons aromatic. And there are 2 aromatic rings. Of course, the compound is aromatic. So except the one, all other are aromatic species. ICl, you can see based on the electronegativity, it would dissociate as I plus and Cl minus, and you can easily guess electrophile would be iodonium ion. So we would get iodobenzene, this as the product. Decimolar solution of HCl and acetic acid are taken in 2 separate vessels at the same temperature. If both these electrolytes are diluted to the same extent, then of course, for acetic acid, the increase in molar conductance is because of 2 reasons. First, increase in ionic mobility because of dilution, and then increase in degree of dissociation, which results in increase in the number of ions. For HCl, yes, molar conductance does increase with dilution, but only slightly because of the increase in ionic mobility. So this would be the correct answer. 0.9 gram of acidylated water require how many Faradays of electricity? So it's simple, guys. H2O, when it undergoes electrolysis, it produces H2 plus half O2. You can see it will need 2 Farad of electricity for 1 mole. So that is 18 gram would require 2 Farad of electricity. So 0.9 gram, you can calculate unitary method. It will come out to be 0.1 Farad. Okay. Aqueous copper sulfate is subjected to electrolysis. So here a difference arises when you use like copper sulfate, silver nitrate. So these metals are less reactive. Okay. They have higher tendency to undergo reduction. Now copper will be deposited at cathode instead of H plus. Okay. Now of course copper has two positive charges. So if you want to deposit 1 mole of copper, you need 2 farad of electricity. So 2 farad of electricity is required for 1 mole copper. So of course using 0.1 Faraday, how much you can deposit? You can calculate. This will come out to be the answer. Aqueous solution of NaCl is subjected to electrolysis using inert electrodes. Weight of the substance obtained by cathode by passing this. So it's simple. When we have discussed this, when aqueous solution of NaCl is electrolyzed, the ions present are these, and on cathode, at cathode, what happens out of H plus and N plus? H plus undergoes reduction. Now the mass of the substance, mass of the hydrogen deposited is ZID. It's simple, right guys? So Z is electrochemical equivalent, which is equivalent weight, which is 1 for hydrogen, divided by Faraday constant, multiplied by current is 4825 ampere, multiplied by time is 20 seconds. So this will come out to be the Faraday constant. This will come out to be 1 gram. So that is the correct answer. EMF of the cell is, so if you try to write the balanced chemical equation, this would come out to be this. Zinc is undergoing oxidation and silver is undergoing reduction. So the equation is this, guys. Okay. All right. Now, if you write the what would be the E naught cell for this? E naught cathode minus E naught anode, and this is cathode silver. So this is 0.8 volt minus anode is zinc on the left side. So it would be minus 0.76 volt. So this is 1.56 volt. Now the Nernst equation says E is equal to E naught, which is 1.56 volt minus 0.0591 by number of electrons, which is 2 for this reaction, logarithm products upon reactants, basically the reaction quotient. So we will not be writing zinc and silver because they are solids. We'll be writing zinc here, ion, which is 0.01. If I write it as 10 to the minus 2, divided by silver की concentration का square, the square of the concentration of silver, which is 10 to the minus 1. So it would be 10 to the minus 2, right? The square. So you can see it is log 1 and it greatly simplifies your calculation. Log 1 is 0. Answer is 1.56 volt. All right, guys. Reduction potential of chlorine electrode in contact. So I just told you what is the formula for the reduction potential of hydrogen. It is minus 0.0591 multiplied by pH. Okay. Now for 0.001 molar HCl, hydrogen concentration is 10 to the minus 3. So pH is of course 3. So this would be a reduction potential. That is cathode. We'll determine that. Okay. So this is the potential for hydrogen electrode, right? And for chlorine half electrode, the potential is given 1.36 volt. Now you should always remember that whenever we connect two half cells to form a galvanic cell, automatically it happens that the half cell which has higher potential, because oxidizing strength is proportional to reduction potential, so the half cell which has higher reduction potential, it acts as cathode, that is it undergoes a reduction, and the half cell which has lower reduction potential, it acts as anode and oxidation occurs. So here you would notice that for hydrogen the value is minus 0.0591 into 3 volt. Okay, so this value is negative, but for chlorine it is positive. So our chlorine will act as a cathode in this case. Okay, so your EMF would be 1.36 volt, the cathode potential of chlorine, minus you would put this value minus 0.0591 into 3 volt. All right, guys. So this would be your correct answer in this case. EMF of the cell, again you have to write the Nernst equation here. So zinc undergoes oxidation to give you Zn2 plus, concentration is C1, and iron undergoes reduction, Fe2 plus, C2 takes up 2 electrons, it forms iron, right? So when you write the balanced equation, it gives you zinc plus Fe2 plus gives you Zn2 plus Fe. All right, and in the Nernst equation, E is equal to E naught minus 0.0591 by number of electrons, which is 2, you can find out, logarithm the concentration of zinc divided by the concentration of iron. Is that clear? Okay, now log A by B is minus log B by A, and we want to increase the EMF of this cell. Okay, so I can adjust this negative sign inside, this fraction would become reciprocal, right? What I mean to say is E would become E naught plus 0.059 on N logarithm iron would come in the numerator and zinc would come in the denominator. So of course the size of ion electrode will not matter here in the EMF. Increasing ion concentration, yes. If you increase the concentration of Fe2 plus, EMF will increase. Increasing zinc, no. So that is a correct answer. So that's all for today, guys. Thank you.